Hi, I want to talk about the Toolbox 6.1, that's editing sound. So that's what we're going to be talking and working this week with the sound. Remember that every time we talk about something that's digital, that means it's in a binary. So we're going to look at the structure of how the sounds are stored in a binary. Binary means this is zeros and ones. And then we're going to be talking about some simple work with the sounds and how can we modify in those areas. So first thing first, we when we're talking about the sound, raw data for the sound. It's stored in 16-bit integers. Uh, that is going to give us negative 32,000 to positive 32,000. So if I have 16 bit, that would be 0 to 15. That would be basically 2 byte. So remember uh, eight, 8 bits or 1 byte. So we're talking about a 2 byte over here, the first byte and the second byte. We combine them together, and because it does have a sign, they vary. So if you look at it the other way around, if you're looking at 2 byte this way, and we're going to be talking about 16-bit, so we can think about 8 bits over here. So we talk about 1 byte on this side and 1 byte on the other side. So if you recall, when we talk about the binary a little bit earlier, you every byte you can have 8 bits, which is going to have 0 to 255. And the way that we were calculating it was 2 to the 0, 2 to the 1, and so on and so forth. So if I want to have these bits on, this would be 1, 2, 4, 8, and so on, and we will reserve the last one for the sign. That's why we are not using all 16-bit. We're just going to use 15-bit plus the sign. So this would be 0 for a positive and on 1 for negative. So this bit would be our sign bit, and we're going to be using 15 bits. So the combination of the 15 bits is going to give us 32,768, 67 to 68 numbers. And this sign here is going to tell us, so remember that's going to be including all zeros. That's why it has one extra one than the other one. So we would have that in here. So if we look at it vertical, that's the way we are saving the sound. So every sound is saved of up to 32 K to minus 32K. And then we're going to be putting these things into a list. So we would have array list of 32, well, 16-bit sounds. That's what it looks like. Of course, when they were doing this to digital binary, they figured out that these files are getting huge, and they came up with some different ways of compressing it. So they have different ways that can be as simple early on, that if we see some things that's close to each other, maybe we can pack it as one, or if it's just good, we can keep track of the changes in a stuff, keep track of everything. So there are different compression systems that's available out there. Your book is not talking about those because they are well, it's not open to everybody. It's proprietary to each one. So your book is suggesting that if you want to use any compressed sound, uncompress it first, and then you can. use it. So we are not going to go with huge files because we're not capable of doing it. We're just going to go with the small ones, and we're going to just play with those things this week, and we can take it to any level that you would like to. So in the DQ questions, if you want to expand this to extra area, you find video in YouTube, or you are familiar with sound and you want to talk more about it, or you are interested or you got interested about it, we can take it to the next level to talk about it. So what we are talking about here is if you take a regular sound, raw data, we are talking about 10 megabyte per minute. That means every minute of sound is going to be 10 million byte. So we are talking about going this way. So we need 10 million byte to cover 1 minute of raw data. Remember, each one of these is 2 byte, so we need 5 millions of this to give us 1 minute of sound. Uh, So again, you find something, you want to uncompress it first, or we can start with just some simple wave uh, files. That way we just use small portion of it. That way we wouldn't have large files. So we are using something called, Audacity. You can use that for compressing, uncompressing, listening to the sound and those kind of things. That's available in this website. You can access it. And then we are going to be using SciPy to read and write our files. So we are going to be reading it through SciPy. So SciPy has an I/O module that has a WAV file, and we can read it. So we are reading this into it. Now, the very first one in the list, remember I have a list that's going, I have a list that's going this way. So very, very first one, it is our sample rate. So that's very, very first one, the very first element. And the rest of it is the actual sound. So we take the first one out for sample rate, and we take the rest of the list. What else do we want to talk about here? So that's the way we're going to be reading, and of course, a similar way to write it. So we can write it this way, and when we are making it, we are talking about data type of int16. That's 2 byte of data. That's we talked about 16-bit of 32,000 to negative 32,000. That's what we are looking at for 16-bit, and that's what it says that the data type is 16-bit, and that's what we're going to be using int 16 to do that. And then we can go through the list, and we can modify stuff. So it has some exercises for here for you to practice on it. And then we're going to have, this is the sample one that you can play with it. So what it does, it says, okay, I am going to take anything that's positive all the way to the top, anything that's negative all the way to the bottom. So this one is going to look more of something like this. Well, maybe a little higher than that. So it would look like something like this. So the negative one is going to be all the way down here. Then positive one is going to be all the way up there. And that's the way it's going to be. You can say it if you want to, or try it if you want to. And then so is asking you what do you think that's going to happen when we do that. So if it's a negative, we're going to take it all the way to negative 30,000. If it's positive, we're going to take it all the way to 30,000. And let's listen to it, see how does it sound like. And that is the sound file for a meow of a cat. So then after we did this and practice on this one, then we're going to have some exercises that we're going to be playing this week and see how far we can go with it. And that's what the assignment is going to be for this week. So take a look at this. Let's talk about it. Let's bring the questions in the class and let's have a good, productive discussion so we can all learn about this. That's all I'm going to talk about, and see you later.